Hi, and welcome to another video about our Arduino starter kit. This is called the Lovometer. This project is used to measure how hot you really are. Actually, in simple words, this circuit is a very simple thermometer that measures your body temperature and visualizes it on a string of LEDs. So let's look at how the circuit is built. There are 5 LEDs on this circuit that are used as an output. So you can visualize the temperature by looking at the number of LEDs that are on at any given time. And so this is an extension to the previous project we looked at when we used 3 LEDs, and now we learn how to use more LEDs, so we go up to 5. But the more important part about this circuit is actually the sensing. In this particular circuit, we use a temperature sensor called TMP36. And the interesting feature about this sensor is that it's a very precise temperature sensor that generates a voltage which is proportional to the temperature that it measures. In particular, this sensor generates 10 millivolts of voltage for every degree centigrade plus 0.5 volts. So for example, if the temperature in this room is 20 degrees, then 20 multiplied by 10 millivolts is 0.2 volts plus 0.5 volts, which is the basic voltage that's always produced at 0 degree by the sensor. So when the temperature in this room is 20 degrees, the sensor will produce 0.7 volts. Now we hit an interesting problem. In this particular case, we were using a pin that was able to measure if the signal was on or off. Was it basically able to measure if there was or there wasn't any voltage applied to the input pin. In this particular case, the sensor is producing a voltage which changes depending on the temperature. So if we want to actually be able to measure the temperature, we need to be able to measure the voltage produced by the sensor. So the digital pin, it doesn't work here, because the digital pin basically says if the voltage is more or less 3 volts, then the input is high, and if the voltage is more or less 0, then the input is low. We need something that is going to be able to give us a number which is proportional to the voltage that it's measuring. Here we introduce the analog inputs on the Arduino board. You can see here that there are 6 inputs on our circuit called analog in, and each one of them is able to measure a voltage between 0 and 5 volts, and it will return a number between 0 and 1023 proportional to the voltage it's measuring. So when the voltage is 0, it's going to be the number returned by by the analog inputs is going to be 0. And when the voltage is 5, the number is going to be 1023. And for example, for 2.5 volts, the number returned by the input is going to be roughly 512. So what we are doing here, we wired up the sensor in a way that we are providing power, the connection to ground, so we're powering the sensor, and then the sensor has a third leg that we connect to analog input 0. So whenever the temperature changes, the voltage changes, the Arduino uses a new instructions that we're going to see in the code later on called analog read that will give us a number that we can use to calculate the actual temperature. Let's try the circuit for a second. I'm going to grab the temperature sensor and see what happens. So you can see now that the LED are turning on one after the other when I touch the sensor. And if I release the sensor now, the temperature is going to slowly go back down, and you will see the LEDs start to turn off one after the other. So now that we see that the circuit is working, we should be looking at the code and understand how we have implemented this functionality. So let's have a look at the code for this example. So if we look at the code, you see some familiar elements like the setup function. So let's start at the beginning. We define a constant called sensor pin that maps the analog input 0, A0, in the code here, you can see A0. And this one allows us to be able to change the input pin if we want to, and it gives a meaningful name to that particular input. So we know that the temperature sensor is connected there. So the code becomes more readable. Then in the setup function, the first thing that you see is that we are using serial.begin 9600. Basically, this is a new function that we have introduced in this example. It allows the Arduino board to communicate with your computer. So serial.begins opens a communication channel between your Arduino board and the computer. 9600 specifies the speed, 9600 bits per second. So this allows us, for example, to print numbers that we read from the analog inputs and send them to the computer, where we can use the serial monitor that I'll show you in a few seconds to visualize the data that comes from the Arduino. Then we find a for loop. The for loop is useful in order to execute a certain number of instructions for a very well-defined number of times. In this particular case, what we are doing, we need to turn 5 pins on the Arduino to become outputs, and we need to turn them off. So instead of writing the same 2 lines of code for 5 times, we use 4. If we look at the code, we see that 4 starts with x being equal to 2. Then every time that we execute pin mode and digital write, x increases by 1. X++ is the instruction that increases the value of x by 1. And we keep doing this until x is less than 5. So when we hit pin number 5, we stop doing this loop. So this is very useful if you have to apply the same operation to a number of pins. So let's delve now into the loop. Inside the loop, we are reading the sensor value using analog read. So we have sensor val equal analog read sensor pin. This will measure the voltage and return an integer number which is proportional to the voltage that's been read. Serial.print prints the number towards the computer, and serial.print ADC specifies that the number that we just sent to the computer is the raw value from the analog to digital converter. The analog to digital converter is the circuit inside the Arduino processor that turns voltage into numbers that we can use in our code. So the next operation turns the number read by the analog to digital converter into the actual voltage. So we specified that the numbers between 0 and 1023 represent the voltages between 0 and 5 volts. So what we are doing here, we are dividing sensor val by 1024, which is the maximum amount, the number of values that are representable by analog read, and then we multiply that by 5. So this float type of variable is a new type of variable that we introduced with this example, that is able to store decimal numbers that in this case, it's needed because we're going to get voltages like 0.7, 0.8, so we need to be able to represent these kind of numbers. Then we follow that with serial.print voltage and serial.print volts. This, again, sends to the computer the voltage computed by the Arduino and the string volts to specify that the previous number was the amount of voltage. Now here is where we actually make the calculation of the degrees. The sensor, as we said, is producing 10 millivolts per degree centigrade and then adds 0.5 volts to all the values. So if we look at the code, we are taking the voltage, we subtract 0.5 volts, and we multiply by 100. Using this formula, we convert the voltage measured by the Arduino into the actual temperature in degrees centigrade. Then we print the temperature, and then we use a new function called println to write the string degrees centigrade. Println, on top of sending the information back to the computer, sends this new line special character that tells the serial monitor on the Arduino to start printing the next line at the beginning of a new line. So this makes sure that all our values that we visualize are all nicely aligned and readable. Finally, once we have the temperature, we need to be able to decide how many LEDs are turned on and off depending on each temperature. So what are we going to do? Actually, we're going to use a series of ifs. In the previous example, we used if-else to be able to decide to execute one part of the code or another part of the code depending on the result of a question, of a kind of a condition that we ask Arduino to verify. In this particular case, we have to verify multiple questions because we have 5 LEDs, therefore we have multiple combinations. So we use a different kind of if combination called else if. So we ask Arduino, is the temperature less than the baseline temperature? If that's true, Arduino is going to turn off all the LEDs. If the temperature is in the first band, we have an if that's measuring if a temperature is more than a certain value but still less than another value. If the temperature is within that band, one LED will be turned on. And then we have another else if that basically goes through every combination of value until we are able to turn on all of the LEDs. So in this particular code that we are displaying here, we are using if-else, else-if, to divide the temperature range that we want to measure into bands. And then we check to see in which band the temperature falls in, and we decide which LEDs to turn on and which LEDs to turn off. Then, through the last else if, we basically reach the end of the program. Then the loop is going to start again, and we're going to go through the same sequence. Measure the temperature through analog read, take the number, turn it into a voltage, then from the voltage compute the temperature, print all of that information onto the screen, and then afterwards decide which LEDs to turn on depending on the temperature. So if now I grab the sensor, the temperature increases, and the if statements are deciding which LEDs. For example, at the moment, this LED is flickering because the temperature is across 2 bands, so it's still undecided which one should be turned on. If I release this, and maybe I blow a little on the circuit, you will see that this LED will start to flicker a little bit and then turn off. So we're now reached the end of this example. We have learned a little bit more. We've learned about controlling multiple LEDs. We learned about reading analog inputs, converting the values into voltages, converting the values into temperature, using multiple if statements to divide values into bands and make multiple decisions, and then how to print all this information back to the computer. I hope that you will enjoy playing with this project, and I'll see you in the next video.